Hello, hello, and welcome. I'm Quinn. I'm a coach at Major League Hacking. I'm super excited to have you here. We're going to be learning R, maybe for the first time. Maybe you've already done a bit of R before. No worries. If you haven't, though, it's going to be so great. I love R. I think R gets bashed on a lot in the community, but I've been told by many hackers who attended my streams in the past that I should do a workshop on R, and so I am. I hope you're all super excited, just as excited as me. And I hope you've been having a good week so far. I think this is towards the end of day one still. So let me know how day one has been. This is the week to learn new things, beginner's week. And I am so excited to be joining you all. It feels like it's been ages, actually, since I last streamed, although it's only been a month, which is, you know, it's how time works, I guess. But it always blows my mind. Anyway. So I'm super excited. We'll maybe give it a minute or two for people to join. I've added a little music. I hope it's not too loud. Feels a little loud to me. I don't know. Hard to tell. It's been really good so far. I'm so glad. It's been good. Learned a lot. That's so good. We're going to continue doing that. We love a bit of learning. Hello. Welcome, everyone. Oh, heartbreaking. Don't worry. It's all recorded. It's on YouTube. After the fact, you can go back and watch it. Definitely do catch up. Really recommend. Also, as a little reminder, please do check in. The link is in the chat. I've just posted it again. Definitely be sure to check in. Maybe I'll put it on a little banner as well. There we go. Definitely do check in. That's the link there. In the chat, feel free to copy and paste it. Checking in is super useful because it means we know which events you're going to, which ones you're really loving, and so we can do more just like that. Also gets you swag, stickers. Who doesn't love stickers? Best thing. Okay, right. I think we'll get started pretty soon. Hopefully everyone's got past all the Twitch ads. I know they can be a bit painful. All right, and I'm gonna share my screen. Now I've got a laptop down here, which means that I can see all of your comments, but I can only share part of my screen. So this is where is it? Oh, okay. I'm having some technical difficulties. You might have to bear with me. Oh dear. Let's give it a minute. Got some happy people excited for R. We've got a couple of questions as well. Data visualization, that's an interesting answer. We'll get to it in a minute. I don't want to don't want to jump ahead. So the first thing that we all need to do is we need to download and install R and RStudio. And I am trying and failing to share my screen and show you all what RStudio looks like. And I think I'm gonna have to give that a go again. Let's see. Okay, there we go. This time. All right. Okay, and I'm gonna add my screen up. There we go. All right, hopefully you can see that. I know it's a bit long and thin. If that's not ideal, I can see what I can do. But this is RStudio. It's your IDE for working in R, and we are going to be using it today. Awesome. So the kind of goals for this session, let's talk about that very quickly. We're going to use R for the first time, maybe, and also RStudio. We're going to hopefully build a little app, and we're going to learn all about how R works. I feel like a lot of people will be like, oh, why do I ever need to use R when I've got Python? I feel like that's a pretty common question. One of the reasons is if you're into statistics, R is very good because it's got tons of stuff built in, and all of the packages are built to be really fast and fluid for development. Sometimes R is a little bit slower than Python, so in production, you're probably going to be using Python. But in data exploration or running like statistical tests, hypothesis tests, these kind of things you might have heard of before, if you've done any statistics courses, it's a bit of a tongue twister, then R is really good. It's much easier. It's much more reliable in my experience, at least. And in my experience as well, getting from the point of nothing to the point of having something looking visually great as well is quicker in R. Certainly if you're trying to build a visualization, a dashboard, that kind of thing. Someone else, I think, said in the chat that it's about data visualization. That's not the only thing that we use R for, but it is great at data visualization. Yes, it's a programming language. That is exactly right. What's it for? Yeah, so data visualization and stats is kind of what I would say. Yeah, this is a great answer. This is actually a really great answer. So it is built exactly for this, and we'll see a couple of the different bits of the R toolkit that make data analysis and manipulation super easy. Okay, the font is too small to zoom in. I can do that, no problem. Is that better? That's kind of huge. Is that okay? Well, this is all right, right? Hopefully, someone let me know in the chat. Hopefully this is slightly better. Okay. So the tools that we're going to be using are R, RStudio, and then a bunch of packages. And we're going to download all of those for the first time. As you can see, I've already got it downloaded. I will re-download it and hope it doesn't just break everything. It's better now? Ah, perfect. I'm glad to hear that. Okay, so I'm going to pop a link in the chat. Actually, I might just reshare my screen as well. Let's do that. Okay. Share screen. You know, I'm going to share my whole screen, I think. And then, okay, so this is the link that you all need to head along to. And then I will share my screen. So hopefully you can all see this. If you head along to this link, this is where you get to. And this is where we're going to download RStudio. And RStudio is great. It's better than like VS Code in my experience for R. I mean, you can use VS Code, and sometimes I do for R, but generally I use RStudio. It's got a whole bunch of built-in bits and pieces of tools that help you be more productive with R. I'm surprised that it allows you to work with Python. I've actually never used Python in RStudio, but if you wanted to, I guess you could. So what we're going to do is we're going to install R here. And if you're on Windows, you click here, or you got macOS and Linux as well. And we're also going to download RStudio for Windows, and you can see random things in here, but it's downloading up here. And if you are on Windows, you do exactly what I'm doing, but you want the base subdirectory. This is if you want to install it for the first time. I imagine it's exactly the same. Yeah, okay, so you've got all of your different options for Mac and Linux as well. So I will give you all a minute to do that. It's pretty straightforward. Yeah, once you've got them downloaded, ooh, let's not do that. Once you've got them downloaded, you can just run them. Hopefully it will pop up, and then yes, will allow you to make changes to the device. But it's currently running, and it wants me to close it before installing a new version. So I'm actually not going to close it. I'm going to just pop it open like this, because that is much, much easier. So hopefully that's all feeling nice and intuitive so far. Yeah, it is doable on VS Code. It's not too bad. There's some things, like if you're trying to do, like if you're trying to generate like markdown files, you're using R Markdown, that can be a bit of a pain because of some of the tools that you need. But it's doable. RStudio just does everything for us behind the scenes, so it's very nice to work with in my experience. So I do recommend it. But yeah, if you prefer, you can use your own IDE. I would recommend having RStudio as well. You can see down here, I've got VS Code and stuff. So do not worry. You can use multiple IDEs. You're not betraying yourself. Yeah, there are a couple of differences. No R project, that's true. I'm glad we're thinking it's epic. I think it's epic too. I'm not sure many people would describe R that way, but you know, I do. Okay, right. So let me reshare just my RStudio again, and then we can maybe get started. All right. Yeah, there's a bunch of things that you can just whip up with RStudio. It is really great for that. Okay, so hopefully you've got to a point where you've got RStudio downloaded. Give me like a yes or like a little emoji in chat if you managed to get RStudio downloaded. Give me like a still installing. Okay, that's good to know. No worries at all. Take your time, everyone. There is no rush. Awesome. So maybe while it's installing and downloading for everyone and getting set up, I'll give a little tour of RStudio. So we've got our console here. This is like running, if you wanted to run some R code, you want to say, okay, X is equal to 42. You could do it here, but if you wanted to just run like a line or two at a time, you can run code immediately in here. So if we instead run that here, great. You can see that that's run and it's stored in our environment, the variable up here. And we'll get a little bit more into syntax and stuff, so don't worry about that right now. But basically all I'm saying is we've got our console down here and we can run little bits of code, stuff that we're not going to keep in our script, but other little bits and pieces. This is, as I've just given away, our little script editor. And then we've got our environment here. This stores all of our objects, which we've created. Now we've got files, plots, and packages down here. When we create plots, they'll appear down here. This will describe all of the packages that we've got installed. If you want to look things up, you can see that, well, there's loads of things that you can look up. This is the normal distribution. Maybe this is what I had up last. I can't remember. Or maybe this is default. I don't think so. But and you can search, or you can just put a little question mark down here and then any function and run it. So we could do that. Okay, that's really unhelpful, but never mind. You can, I promise. But maybe like if we did, yeah, if we did norm, there you go. So it's brought up this page. So all of your various different bits and pieces are generally documented quite well. R is really great for documentation. There's a lot of it, and there's various different bits and pieces online. I do recommend just giving it a Google if you're ever stuck, because there's so much out there. R is used very widely in academia and various other contexts, so it's great for that too. Cool. We got some people who are happy. I think this is still installing. Yeah. let me know when you're ready and we'll move on. We've got a question. What's your normal running workflow when starting up RStudio? So we'll go through that in a minute. We'll do a project right from the start. Yeah, so don't worry. You're so eager. That's all good though. We've got some people who are done. That's good. Okay, I'm going to slowly start moving on. But don't worry, it's going to be nice and slow. So it's going to be all right. Okay. Cool. So as someone's already mentioned, there's these things called R projects, and they are super nice. They allow us to keep everything contained really well, and we're going to make one now. I hope everyone is kind of ready. One thing to check is that you've actually got R installed correctly and you've got RStudio set up well. And you can do that by going down to the console and doing R version.string. And if we run that, it will tell us the version. You can see that I updated mine pretty recently. So I've got 4.4.3. Probably you all have this as well if you've just installed it. If you don't, you are probably on an older version, and I think it will still work, so don't worry. You can, as someone mentioned, set your working directory and things, but we're actually going to avoid that because if we use an RStudio project, it keeps our file paths nice and tidy and everything is just relative to the project. That actually makes it better for working collaboratively, because if you've got a different working directory to someone else, a different setup, it doesn't matter because the project handles all of that because it's relative. So no worries at all. So we'll get to that in a minute. You will probably have, let's not save that. You'll have something like this. This is probably what you all have. It probably looks like this. Actually, one little thing to mention is if you want, you can change the appearance. I, as you can see, have already had mine changed. You'll be starting on something like, this one probably. It's a bit ugly. Yeah, not the most fun. This is probably exactly what you have right now, hopefully. And then you'll have your own files down here. This is just random stuff. But I'm not going to use this because it's, horrific on the eyes. So I do recommend you change it to your taste. I can't even remember what I had it on now, so that's terrifying. I don't know. Were we on ambience? I don't think we were on ambience. I feel like I was. You know what? We can change it up. Let's go with this. This is great. Okay, this is maybe what I had actually. So I can't even remember. Okay, so Dracula, yeah. Well, anyway, pick your appearance to your taste. And yeah, by this point we have got RStudio installed. We've got R installed. We've checked that it's kind of vaguely working, and we're gonna make our first project. And you're gonna do that by going File and then New Project. And this is what I would recommend you do every time you start a new project. No matter what you're doing. So if you rock up at your hackathon, you're like, right, I'm going to build a project in R. This is what you should always do first. We generally don't want to save our workspace image. This is kind of just a record of like the different objects and bits and pieces that we've kind of created. And actually, we're just going to create them. If you have a project and you're closing it, you should generally not save because you want to create them again when you next open it up. That means that it's consistent. So if you're working between different devices, or you've got different people in your team working on the same project, there's not stuff which is kind of stored locally that actually hasn't been created somewhere else. That can get very confusing. That's not great. So we won't do that, especially because all of this is just, random, right? So we click New Project, and now we've got some options. We can make it in a new directory. We can make it in an existing working directory, or we can check one out from version control. So if you wanted to clone a project, this is where you would do it. And if you're working in a team, again, this is what they might do. But we're going to start a new project ourselves. Hopefully you're familiar with Git, but this is not really the focus of this workshop. If you want to learn more about Git, I think we've got a couple of Git and Git Copilot as well. GitHub Copilot even. Workshops this week. I think there was maybe one today or maybe one tomorrow as well. Not 100% sure, but definitely check them out if that sounds new to you. Okay, and then we're going to click New Project, and we're going to call it Hack Viz. I'm going to call mine Hack Viz 0 because I've actually already got Hack Viz when I was testing this when I was prepping for the workshop. So, but you would just call it Hack Viz, and we're going to be making, as the name might give away, a little hackathon visualization project. So nice and straightforward. I'm putting it in my projects directory. This is already set up. You can move things around. You can put it wherever you like. I'm going to cancel that. But this is where all of my projects live, so I'm putting it there. And you can create a Git repository if you like. You can also create or use RENV. And I recommend this. It tracks all your packages. If you're used to working with virtual environments, it's basically the same thing. So we will click Create Projects. Okay. This is why I needed to put the 0 in. I forgot to put it back. There we go. Okay, so you've now hopefully got a project. It's hopefully called HackViz, maybe HackViz0 if you copy me directly. And we're switching to it now. Wow, look at that. And now we're in our projects folder. We've got a little working directory set up, and it's got a git ignore. It's got all of these different bits and pieces, which probably look very strange. The biggest one is, well, the biggest things to note are this and this. So this is, like I said, it's just basically our virtual environment, but for R. And this is kind of like your requirements.txt. We can freeze all of the packages that we've got installed into here, and then someone else can reproduce the exact kind of setup, which is obviously very ideal if you are working, again, in a team at a hackathon. So perfect for Beginners Week, I hope. In R, it's called locking. That's why it's a lock. You wouldn't typically call it freezing, although you can use whatever terminology you want. Cool. Right. I'm not seeing any questions, so I'm going to just keep going. Hope everyone is happy and then it's all making sense to you. Okay, perfect. And now I think probably we want maybe some folders here, and we could make them ourselves. You could do this. You could also make new files here, but actually let's use the console quickly just to get used to it. And we're going to do this. This is just going to create, let's see where that pop up there. We'll do some explaining for us. There we go. Okay. So this is the manipulation of directories and file permissions. Excellent. And these functions provide a low-level interface to the computer's file system. Great. So we're going to use this, which sounds exactly ideal if we want to make a folder, to make a folder. And we're going to do it by doing this. And we'll say show warnings. And we'll set that to false because I don't care for having warnings. And look, wow, we've got a data folder. It's empty. That's fine. We'll also make a scripts folder 2. Scripts show warnings equals false. Perfect. And now we've got a scripts folder. Yay! This is great. This is great. Okay. And someone said, oh, how do we get that? You know, what was it? How do you get the untitled one thingy? Okay, the untitled one thingy was a script or an R file. And we can create them by going up here and clicking new file. There's a bunch of other different bits and pieces here. You know, you can click create a project instead of going into here. You know, I recommend having a little look and getting familiar with all of this. We've got version control up here, and actually, if we click along to this tab, this is the Git tab. You can't really. Okay, I can't expand that very easily. Oh, I can. Let me just do this. There we go. Haha. And we can, you know, commit and push and pull and whatever to a remote as well. So you can link this up with your GitHub. It's all, you know, pretty kind of standard version control stuff. Again, if you're not familiar, definitely recommend checking out some of the Git workshops that we've got this week. But I'm not going to deal with that for now because it's not really focused, and we're just going to create a little project anyway, so we don't need to worry too much. Okay, yours just shows hackviz.r project. You ran the create and it created data folder. Okay, that's cool. So if you don't have these bits and pieces here, the git ignore and your virtual environment folders, probably when you created a new project, oh, yeah, there we go. You didn't tick these. So if these are unticked, it won't create those files for you. Yeah, but if we tick these, it would. So I ticked them, it made the files. So if you want to, you can remake your project and do that. I don't actually think they're critical. We'll maybe discuss how to very briefly interact with the kind of our environment, but hopefully you can kind of work out how to get those in by just ticking those boxes if you are super interested in doing that. But first, like I said, we're going to make a new file. So I just clicked this little icon up here, new file, and our script. We can make, you know, a whole bunch of them, but we don't need them. So we'll just make one. And we're going to save this before we do anything. We're going to save it in scripts, and we'll save it as o1 basics.r. Okay, and that's, you know, pretty standard stuff. But first, I think, as we discussed, maybe we want some packages, right? And if you don't know what a package is, that's totally okay. It's like a library of functions, right? You install them once, and then you just load them each session. So we could in here put our installation command, and our installation command is install.packages, and then we can put them in here. It could be Shiny, which is what we're going to use to make our little web app UI. But actually, what if we wanted to install a whole bunch at once? This is pretty slow. Well, we can use C, and that creates a vector, and we can create a vector of our packages that we want to install, and we're going to want Shiny and also Tidyverse, and also DT, which allows us to create interactive tables, and then we also want Shiny themes, which allows us to make our apps prettier. It's not very happy with me for some reason. Oh no, there we go. Okay, it's fine. So I'm just gonna reshuffle this. Now, this goes off the page, but that's fine. On yours, hopefully it doesn't, because hopefully you'll have a less narrow screen than me. And we can run this here, and we can run something by clicking run if we highlight it, or just if we put our cursor on the same line as it. And I'll do that, and it will pop down here. Now, actually, we don't really want this to live in our script, because if every time we run this script, we run this command, we're going to be reinstalling something that we've already got installed. That's kind of silly. We don't need to do that. And so actually, I'm going to delete it, and I'm going to go down here, and I'm going to stop it from running. And I'm going to say, actually, instead, why don't we just run it in the console, right? And this is, you know, a reason for you to use the console instead of the script, for example, for things which you're only going to run once, right? And I kind of mentioned that earlier. Now, we already ran it, but then we canceled it towards the end. But we'll rerun it now from the console and show that we actually can do that. And it's going to think, and then it's going to say, oh, I'm going to install all the stuff for you. It might say I'm going to update some stuff. You've already got some stuff installed. That's fine. We'll click Y for proceed, and it's going to install. Now, if we want to import these, if you're familiar with Python, you'll be like, oh yeah, I know how to import numpy as np or whatever, right? You know how to do that. Well, in R, the equivalent is library. You type library and then the name of what you want to essentially import. We don't really call it importing in R. We would say that we would load the packages, and we do want to do this every session. Unlike installation, we want to do this every session, so we will have it in the script and not in the console. And so we've got library Shiny, and we also have library Tidyverse, and library DT, and then library Shiny themes. So let's run all of these. And it's pulling them all in, loading them all up. Great, we can see that Shiny was fine. Tidyverse has said we've got some conflicts even. I don't think we're going to really care about this for now, so I wouldn't worry too much. And then we've got some bits and pieces which aren't interacting nicely, but that's okay. It will still work for us today. As with everything, there are always conflicts, and unfortunately in R that's not, that still happens, but I would say it happens less than in Python. Certainly if you're used to using PyTorch, for example, you are very used to conflicts and installation problems and so on. But in general, in R, we have a much better time. Okay, so wow, we've got a script up here, and we've imported some libraries. Essentially, we've loaded some libraries. I'm going to just save that again, and we've actually got this in our script folder down here. This is good. This is a great start. Okay, you get that there is no package called Tidyverse, so you haven't run the installation command yet, is what I would guess. This is the command that you need to run. This one here. Install.packages, and then you want Tidyverse in there. I put it in a vector, but you could equally just go install.packages tidyverse. If you have done that and it's still saying that there's no package called tidyverse, I'm not 100% sure what could be causing that problem. Check the output in the console when you run the installation command, and definitely try installing it just by itself, so not with all of the other bits and pieces. Just do this command, and hopefully it will work. Oh, it's a typo? Okay. Phew, because that could have been confusing. Okay, right, and I'm going to put a little comment in here, and we're going to learn how to do assignments. So this is going to be like the kind of fundamental little commands in R. Yeah, let me know at any point if there's anything that you want to know that I haven't explained. Yeah, I think we're going to go through basically all of the essentials. If I miss anything, let me know. But I think these should leave you feeling pretty happy. Okay, we got a question. Is there a way to import or load the packages? Okay, so we got a question asking, can we do this in one line? I don't think so. I've never seen it done in one line. And certainly my suggestion would be that you wouldn't, because if people want to run just bits of your code, they can run, okay, I don't want to import this, I'm not going to use this. Like, let's say you've got a script which produces some visualizations and then produces an app that it puts the visualizations in. Maybe they just want to produce the visualizations, they don't want the app, then they wouldn't need Shiny, so they wouldn't want to load it because it's more time than they need. So I would say it would be bad practice to load them all at once if you could. I'm not 100% sure if you can. If you could, you'd probably do it like this. I don't think it will like this, but it might. Yeah, package must be a length one, so it won't let you do it, which is for good reason, in my opinion. So the answer is no, as far as I know. That would be, yeah, exactly. Modular code, we love that. Okay, so let's get started. Right. First thing to learn is assignments. And let's, not tabbed in. We'll add a little comment here, and this is going to be the first section of the commands that we're going to learn. And so we can set a variable and we can assign a value to it, right? And just like in any language, we can do strings, we could do a bunch of different types, and we can also do numeric assignments. So I did this earlier. If we do this and run it, it's going to pop up here. And by the way, when I'm running these things, I'm pressing Control and Enter. You can see that every time I press Control and Enter, it pops in down here. You can also click the Run button. It does the same thing. You'll see that it's the shortcut there. Yeah. So that's how you run a line in RStudio, and that is how you assign a value to a variable. Now, this is a numeric data type, kind of like an integer or a float in Python. We can also have characters, and you might be thinking, well, Quinn, you've not explained the weirdest bit. Why are we using an arrow instead of like an equals? Doesn't equals work? Yes, an equals does work. We could set this to 32. You see it's updating here. It's idiomatic in R to use this assignment key instead of the equals. It does also work. There are a couple of times where it won't work. Off the top of my head, I think when you are using functions, sometimes it can get a bit funny about using the equals symbol. Generally, just avoid it because it can break down a little bit. So that's the kind of short answer. And then we might want to use different data types, right? And there is actually a shortcut to typing this, by the way. You don't have to do the little, you don't have to do the arrow and then the dash, although you can, it's literally just those two symbols. But if you press Alt and then the dash key, it will just do this for you. You can see I've got loads of them now. And I'm going to delete them all again. But that's the quick way of doing it. Definitely will save you a lot of time. So don't be typing this. Ooh, don't be doing this. It's very slow. Do this. So Alt, your little Alt key, and then the dash. All right. I'm seeing no questions, so I'm assuming everyone is happy. And we can just basically set a string or characters in the same way. And we could say hello world. And there we go. We've assigned the value of hello world to our greeting. We can use what's called logicals. And these are kind of like your Boolean variables, true or false. So we could say true. And bear in mind that these are case sensitive. So you want explicitly true or false and not true or false. If you're from Python, you might be feeling with these. Do not do that. Do not do that. And then we could say, define any other number as well. We don't have to just use integers. We could say x is 4.2, and again, it's going to update there. Awesome. But we could say, we explicitly want it to be an integer, not numeric. And so we could put 42L, and then this is explicitly an integer now. All right. That's kind of the basics of assignment. Hoping that makes sense. Let me know if I'm going too fast or too slow. I'm happy to go a bit quicker as well. Give me an emoji in the chat if you are caught up and happy. Seeing no emojis. Let me know. Let me know. We'll give it a little pause otherwise. Gonna take a drink of water. Okay, we've got some happy emojis. That's good. Happy hackers. Great to hear. Okay, in that case, we will... Oh, awesome. Awesome stuff. We will keep going. Now, you might be thinking, well, we defined greeting as hello world, but how do we print it? Well, actually, it's super easy. You can just run the line of the variable, and it will print. You can also do print, and it will do it as well. It said a little error there, but it went away because it was catching up still. We're typing too fast. So yeah, you can automatically print anything by just running the variable name. And you can see here that the L has gone. This is just an integer. Awesome. There are ways that you can kind of print in like prettier ways, especially when you're dealing with data and stuff. But this is great for us for now, I think. So hopefully we are pretty happy. Okay. We've got some more questions in the chat. Strings are always double quotes rather than single quotes. Okay, I'm glad that we've managed to troubleshoot this ourselves. I would always use double quotes in R. I think that's just kind of habit now. I actually think you can, yeah. As our other friendly helpful hacker says, you can just yeah, exactly. It just stores it with double quotes. You should probably use double quotes. I think that's the kind of default in R. But if you use single quotes like I just did, you can see it actually stored in the same way. So it's there we go, interchangeable, just like I think Python. That's what you mean here. Yes. It says object greeting not found. Okay, what I'm guessing is that you maybe either typoed or you didn't run this line. So if you see greeting up here, it will not say that because we've definitely got the object, in our environment. Yeah, okay, we've got this is another great point. Yeah, if you've got single quotes in your text, you would have to use double quotes. We've got some troubleshooting going on. This is fine. This is great. It's in values. Okay. That's good news. That's good news. We're good. Perfect. I'm so glad. I'm so glad. Okay. So hopefully we've got to a point where we can define our variables and we can also quite happily output them. Okay, so the biggest thing to get onto, which makes R really different to Python, is vectors, in my opinion. Again, this is maybe not the biggest difference, but it certainly is one of the bigger ones for me. And vectors are our basic building block in R. So a scalar is just a vector of length 1. And hopefully you know what a vector is, but you can think of it kind of like an array. And in maths, a vector is really great, when you're doing like calculus and linear algebra, you would use vectors pretty commonly, especially when you're dealing with matrices and things. And that's super useful. But actually, in R, we can put anything into a vector. And you would have seen us use vectors already because it's just with this little c. So this is a vector here. This is empty. But we could put some numbers in. And now we've got our vector. And it's up here. We can see that we've got from the first value to the fourth value. And this is probably looking like slightly odd to you. You maybe can't place your finger on why it looks odd. And the reason is actually R is indexed from 1, not 0. So in Python, for example, this array would have length 4 starting at index 0 and ending at index 3. 0, 1, 2, 3. But in R, we start at 1 and we end at 4. So 1, 2, 3, 4. That's probably worth mentioning. It might come up now and then, especially when you're doing for loops and things. Awesome. So we've got a vector. Can we do vectors with more than just numbers? That's not something you'd normally do in maths, is it? Well, you can in R. And that's convenient for us because it's actually how we installed all the way up here all of these packages. We ran, where is it? We ran this command, and you can see actually we've got a vector here, and it's a vector with names in it, and we could have some names here as well. There we go, and we can run that, and now we've got, you can see here, character data type, and we've got from index 1 to index 3. So again, note the 1-based indexing. We can do it with basically any data type. I think literally any data type. I don't think there's anything you can't do it with. So you could do it with Boolean values as well. We run that, and there we go. And like I said earlier, this is called a logical data type. Logi for short. This is character for short. This is numerical for short. And 1 to 5 again, starting at 1. Cool. Now, this is pretty neat because when we're doing maths in R, right, we could do, let's not use capital there. We could do x is equal to 1 plus 1. X is equal to 2. Great, great, great. And then we could say, well, what if we wanted to add 1 to all of these? How would you do that in Python? You might say, and I'm going to write in Python pseudocode so don't get kind of confused here, but you could say for, I in nums, in length nums, and so on, right? You might loop through it, and then you go, okay, well, nums I, and then equals I plus 1, right? You could do all of this. I would say, yeah, great, whatever, fine. There's probably better ways of doing it in Python as well. But in R, it is even simpler. This is one of the most beautiful things about R, is that we could say, okay, nums plus 1, and we could say, literally, nums plus 1. It's that simple. And so at the moment, nums is 10, 20, 30, 40. You can see that here. If we run this line, we get 11, 21, 31, 41. It's that simple. And this is called vectorized maths. It operates kind of on an elements-wise level. Okay, I don't know why I'm typing all these helpful comments out when the screen is too narrow for you to see them, but hopefully that's helpful. We can do that with basically any maths operator or math operator, I guess, if we're being a little bit American. I don't know where everyone's tuning in from today. I'm probably tough on my accent that I am from the UK, but it's super cool at Global Hack Weeks. I mean, the clue's in the name that we're joined by people all over the world. I love that. So that's awesome. And just like that, we've done some more math, if you wish. And we've multiplied our nums by 2. And so we've got 20, 40, 60, 80. Great. This is great. This is very efficient. And because it's vectorized, it is, as you can see, super fast. Now, another useful thing to note, when we are using R, we're normally doing statistics or data analysis or data visualization. And one of the biggest problems when we're dealing with data is missing values. This is probably something you're familiar with. And if you've done any kind of data processing, they are often the bane of your existence. And that's because they are unpleasant to deal with and can cause problems in our calculations. But generally, R handles them very, very well. So in R, missing values are called NA. And this is just equivalent to missing. And we could define this. You can see it pop up there. Cool. We want some people asking for the link for check-in. Yeah, no problem. So if you haven't managed to check in already, the link is, let me grab it for you. Don't have it open anymore. Let me pull it up. This is a good time to take a breather anyway. Okay, yeah, definitely do remember to check in if you haven't already. Link is down there in the chat. There we go. Okay, perfect. So we've got a vector now with a missing value. And that's fine. What if we wanted to calculate the mean of this vector, right? So let's say we wanted to calculate the mean of nums, right? That's pretty straightforward. Again, really nice and easy. We could get the documentation on this command and it will tell us all of the arguments that go in, right? This is super, remember this little question mark that I showed you earlier. It's a super easy way if you're like using a new function and you're not sure quite how it works. This is perfect, but what if we do it on has NA? Well, it's got a missing value. What will happen? Okay, that's not great. So we've got our vector, but it's just going to tell us that it can't calculate, basically. This is a missing value. And it's saying, because there's a missing value, we can't. And, if you've got like a whole column of data and you've got a handful of missing values and you still want the average, ignoring the missing values, this is not very useful. However, let's see if we can do something about that. Let's read this. Okay, arguments. So we put in X. This is our R object. There are methods for numerical and logical vectors and data. Oh, and sorry, dates, date time, and time interval objects. Wow, that's super useful, isn't it? But what if we're missing stuff? That's annoying. Oh, interesting. What is this? So we can actually ignore, basically, missing values. And this is a logical, so we can use that capitalized true or false syntax that we learned earlier. So let's try that. Let's see if we can do na.rm, and then we'll do true. So basically saying remove NAs. And we'll run that, and we get 1.5, which you can see if you add up 1 and 2 and then half it, you get 1.5. That's the mean of 1 and 2. Great. Okay, so we can deal with missing values pretty easily in R so far. That's super nice. What if we have some like other weird things going on? Like what if we divide by 0, or we divide by 0 with a negative, or we divide 0 by 0? What do we get? Okay. So R handles loads of things for us. And this is just another neat little example of some interactions that happen in R. This will vary from language to language, obviously, so being aware of things like this is useful. How do we do indexing? So we already vaguely discussed indexing in R and the fact that it's 1-based, not 0-based. Let's make a little note of that. And we could take our little vector with our numbers in, and let's say we wanted to get the first element out of our vector. How would we do that? Any ideas? Any ideas? Any ideas in the chat? I can see we've got a question, but I'll wait until people answer this and I'll come back to your question in just a moment. So any thoughts on how we can get just the first element out of this vector? Any ideas? Yes, perfect. Thank you, everyone. So if we put in 1, that is going to be the correct way of doing it. And we can see we get 10 out here, which is our first element, 10. And I'm glad that's sunk in. A little quiz for you all there. If we wanted to get a range of them, let's say we wanted to get the first 3, we can just do this. And you can see we got 10, 20, 30. That's the first 3. Perfect. Okay, what if we wanted to, I don't know, filter our vector? Well, we could actually just pass in another vector, and we could pass in a vector of logicals. And I know people were looking at this going, why on earth would we ever use this? But actually, let's use it right now. Let's delete that so it's the same length and pass it in here. So we'll rerun this line. You can see I've just rerun it down here. You'll need to do that. Make sure it's the same length. And we'll pop it in here. And great, we filtered based on a vector of logicals. So we got just the first and the third one out, 10 and 30. Great, that worked really easily. We could put it in here. Just directly, and that will do the same thing. But hopefully it's starting to make sense that we can use vectors in everything in R. Vectors are really great. Okay, and then just like in Python, we have data frames, and you can use them in, I think, fairly similar ways, to be honest. Let's say we wanted to have a data frame of our little people, and so we could say name equal to names, and then let's say we wanted to have, I don't know, a score that they got in a test, right? So we could add in a score variable into our data frame, and let's just say that we're going to use a vector again, and we can say, okay, Ada got 95, and then Bob got 88, and then Charlie didn't study, Charlie got 12. And then we can run that, and you can see, again, it's popped up here in our data, and we can click on that and view it. Pretty neat. Got name, got score. Pretty straightforward. And we can see it's got 3 observations of 2 variables. So we've got 2 variables, name and score, and then 3 observations. Observations are just our rows in a data set. And it's similar to if you were running an experiment and you were, let's say maybe you were trying to calculate the average height of a daisy. Every time you recorded a daisy, you'd add it as a row in your data frame, and that would be an observation. That's why it's called that, from observing things literally. Cool. And then we can also use what's called a tibble. And tibbles are just another way of storing data. They come from tidyverse, so they're not in base R, but they are really great. They're kind of table-like structures. And we'll just do exactly the same thing here. 95, 88, 12. You can see that's here as well. And if we click it, we get the same thing. We can see, again, it's basically the same. And we use them because they print out nicely, and they can just be a little bit nicer to work with in some cases. There we go, a little tibble there. And that's our data frame. Cool. You can see here it's got some more information on the type of the data types that we're dealing with, and it also describes the shape, that is 3 observations with 2 variables. So that's pretty neat. Some small little things to know. Great. Okay, and let's say we want to access just some columns in our data frame? Well, in R, you can do that by using this symbol. And then you can put in the name of your variable, and it's already prompting us with them. We've got numeric, we've got character. Let's go for name, and it will print out all of the values in that variable. And we can also do this, and that's some similar kind of functionality, just in a slightly different way. Cool. Hopefully that's all making sense. You can also do it with a table. So I'm on a, this is going to be actually a comically difficult thing to deal with. I'm on a different keyboard than normal, and it doesn't have, let me copy and paste it, doesn't have this symbol, this bar. But we use it a lot in R, so I made a mistake by using this keyboard. Unfortunately, I don't have another one with me, but it's fine. I will copy and paste this. And this is called the pipe operator, and we will kind of discuss that a little bit later. But we can, if we so choose, also grab out the score variable from our tibble. It's a little bit more of a pain, but that's fine. This is just for completion's sake, but generally you don't really need to know that for now, at least. Cool. Oh. So I think we're making fairly good progress. We're about an hour in, and I think we're kind of getting to the point where I hope a little bit familiar with R, and it will be great to make a visualization. I've run out of water. I have a tremendous headache, so I might go and top up. Keep hydrated, everyone. Very important. But first, I think let's finish off quickly a couple of extra bits and pieces. There's some things which I maybe haven't discussed and I think would be good to go over, and so I might do just that. I think we've covered objects, we've covered data types pretty much. You can also make lists in R, and you can do that by, for example, just typing list and putting anything in it that you like. Bear in mind that a list can have all different data types in it, which is one of the things that makes it different to a vector. So we can store everything and anything. It's called heterogeneous. Yeah, I don't think I use lists all that often, but certainly not as often as vectors. You can also use matrices, and you can pop in whatever you like. You can see here I've just made a quick 2x2 matrix as well. And you can probably already see that this is kind of built for doing statistics with, working with data. It's very close to the numbers, unlike something like Python, which is a bit more production and engineering ready. Still great at dealing with data, don't get me wrong, but it's not designed for it, whereas R is designed for it. And so if you are really into building ML models and getting your head stuck into the data, R is actually a really great tool. So I do recommend it for that. There's a couple of bits and pieces that we haven't discussed. One of them is reading data. We'll do that in a bit. And we haven't done much data wrangling. We'll also do that in a bit. We also haven't looked at dates very much. Dates, obviously, a useful and very common data type. And it's something that we can deal with in R much better than in Python, in my opinion. But again, I think I might leave that for a little bit because it's not super crucial, and I really want us to be able to build an app ourselves. One thing I think is worth mentioning, I don't actually think we'll use it a ton, if at all, today, but you probably want to know how to do kind of your control flow style stuff and functions and so on. So we'll call this control flow and functions, and we'll just very quickly type it out. So in Python, you might do for I in range 3, for example, and then you might do print I, right? In R, what we do is we say for, and then we have brackets like this containing the statement that we're going to be kind of looping over, and we'll say I in 0 to 2. And obviously, because Python indexes as 0, this is going to be this is going to print 0, 1, 2. In R, we would do 0 to 2 like this, and this is just the kind of same slicing functionality as we used here. And then within this, we would type what we want to actually be executed in our function. So that might be print I. And hopefully if we run this chunk of code, that's what multiple lines of code in R are called, chunks, it will print 0, 1, 2. And if we run that, we get 0, 1, 2. We can also rerun the most recent portion of code, just like that, as a little reminder if you don't want to be clicking Control-Enter for whatever reason. If we wanted to, and I think someone asked this earlier, I've just seen another question, but for now I'll answer this first. I think someone asked this earlier. If you want to rerun a bit of code, you can. Like I can just run this, or I could just run this, or I could just run this, or I could run this. Like we can jump back and forward. You can also run the whole thing, and it's just run literally everything again, very quick. But you don't have to. But yeah, you can select multiple lines, as many as you want to run. We've got a question, where do all of these bits and pieces come from? They came from tidyverse, as someone has nicely pointed out. Tidyverse is basically something that allows us to work with data even better. Base R is great. Tidyverse is beautiful. Basically, anyone who ever uses R will use it, and we will talk a little bit more about that in a bit. But it's it provides lots of useful things, and some people would say you should learn base R before learning tidyverse. You can if you wish. I would recommend learning tidyverse off the bat. It's very, very useful and very important, and you might as well just learn it. One other thing you might be thinking is like, oh, like how do I make a function? Like in Python, I can just define my function, and then in my function, I can, you know, it's not great. I can do whatever, right? I can +1 to my thing, and we already know that if this is a vector, we can just do that anyway. So this is kind of a pointless function. But for argument's sake, in R, what you would do is you would do the same assignment operator to whatever you want your function to be called, and then you would say function x. You can see function here has changed color. If we wanted to, we could ask can we ask? Maybe actually it won't let us do that. No, okay, it won't let us do that, never mind. If you want to, you could Google how functions work in R. Unfortunately, the documentation will not explain it natively unless I typoed and didn't notice. And in the same way, we're going to use curly brackets to define what's inside our function. And that's a pretty consistent way of working within R. And we don't have to return anything. We can just do that. Awesome. I hope we're kind of fairly happy now. Great. Seeing no questions. This is pretty good. So I think we have fairly comfortably, excuse me, got to grips with all of the basic things. And if you use Python, you're probably hopefully familiar now with the basics in R. And if you could do something in Python, you would maybe know how to do it in R. Just as a little, or as I didn't actually run this, we could run this on, you know, whatever we like. And there we go, it's adding 1 to it. That's how you run your function. Yeah, there you go. We could define a more complicated function. We could say, okay, we'll do x times x, and we'll call our function square. You can see that if I just control enter at the top, it will jump down through the whole function, and then we could type out square 2. It's going to make it 4. Square 25. It's going to make it 625. But we actually also have functions that are built in to do these things, and we can check out all of our various mathematical functions here. There we go. So we could square root our value back down again using a built-in function if we like. And there, we've even got some examples. Look at that. What does this do? Wow, I didn't realize it could just run straight there. There you go. And this is an example of a very nice little R graph, which doesn't show particularly well on my screen, but there you go. Okay, perfect. Right, so we've got the basics of R, I think, pretty much nailed. One thing, again, one last thing, just before I go off and have a little water break and let you all have a little breathing room, is this pipe operator that I mentioned. You might be thinking, what on earth is Quinn talking about now? He's gone crazy. And that would be fair enough. I am, a little bit out there. I'll accept that. Where did I put it, actually? I think I deleted it. That's okay. Right. So the pipe operator looks like this. And it passes whatever you've got on the left side here into the right side. Okay. And this is really great for us because without this pipe operator, nested calls can be quite complicated. So, for example, let's say we wanted to manipulate our data, and I'm going to use some functions now that you don't need to understand yet, but let's say we want to manipulate our data, and we're going to use the table that we created with name and score, and we want to set score2 equal to score times 2. And then we want to do this maybe. Cool. What I got wrong? You can see already why we use the pipe operator. Wish I could see all of this at once. We've got mutate, and then, oh, that's why. That's not meant to be there. There we go. Okay, and now we run this, and you can see this is horrific to read, right? You can't tell what argument is in what. We've got function nested in function, and it's just unpleasant. And we could see that in result 1, we've got the table that we already had, and we've got an extra column where we've doubled the score. Fine. That's, we could kind of probably work that out by this, and it's just not very helpful, is it? It's not very clear. It's kind of confusing. It's really hard to track what's going on. But if we use the pipe operator, we can say, okay, we're going to be using our tibble, our data, and we're going to first select the variables. And again, I'll talk about these. Kind of little functions for manipulating data shortly, but for now, just bear with. You can see that this is immediately much simpler. We are taking our data and then selecting it. This is what we're doing here, but we're laying it out much nicer. And we can then mutate, which allows us to manipulate our data. And in this case, we're going to times it by 2. And then we can arrange it into our desired output. And then if we run this, and then we run result 2, we'll see that we got the same thing. right? And I don't know about you, but I would much rather read this, where we can see all of the different steps that we have one by one, linked up with a pipe operator, than this long, confusing mess. And so hopefully that's making a little bit of sense to you. If you've seen any R code before, you might have seen an operator that looks like this. This is an older form of the pipe operator. I think it's depreciated, or you might be able to use it, but I wouldn't recommend it. This is the one that you really want. I do recommend using this all the time. It's very good. Okay, so these are the basics. We've done a good job here. Oh, I did delete the pipe operator earlier. Yes, thank you. Good observational skills. We've got a little question in the chat. You're having a synthetic error, expected token error during new code space in your repository. Can you give me like more detail on what you're running exactly? I'm not 100% sure I'm understanding. Is this in following something that I've done? This isn't an error that I would expect to have seen at any point. Maybe if you could explain a little bit more about what you're trying to do and what's happened, I'll be able to help you out. Okay, perfect. Right, we're going to be taking a very short break. So please bear with me while I go and fill up my water. And definitely make sure that you've got some water. Take a little snack break yourself, maybe. We're gonna be back in 5 minutes. I'm just gonna put a little note. There we go. Okay, so let's give it a pause. Catch up if you aren't up to date yet, and if you've got any questions, think about them and pop them in the chat for me. I'll be back very shortly, and I'll see you all soon. Definitely take a breather, and I'll see you in 5. Hello, hackers. Welcome back. I hope you had a nice break. I've got some freshly filled up water. Tastes delicious. I love a bit of water. Hydration, H2O, it's great. I can see we've had some questions in the chat. That's amazing. Love to hear it. So I'm afraid I'm actually still unsure about the error that you're talking about. I think you'd have to share more specific code and details. Yeah, I'm not 100% sure. If Copilot's created a lot of your code, if you're working in R with this workshop, then I wouldn't recommend kind of doing it with Copilot, just because when you're getting to grips with a new language, it's best to do everything yourself to get familiar with the basics. But if you've got a question related to a different project unrelated to this workshop, then I would recommend maybe asking in the MLH Discord. There's loads of people in there who are able to help. For now, we're going to focus up on our project here, and we've had a question about how can we basically connect everything up with GitHub. Cool. This is a good question. So if you've already created it with a Git repository, you will have your git ignore, and hopefully you will be kind of vaguely set up. You can also head along to the terminal and type in, but we were already initialized. It's just reinitialized for us. It's interesting that it uses master and not main. It's a bit old. Interesting, isn't it? We've got our git ignore in here. What I would recommend is, oh, that's not what I wanted to do. What I recommend is that you pop various bits and pieces in here that you do not want to be tracked. You can see by default it started off with these. That's pretty good. You might also say, actually, I don't want my library being tracked, because why would we? So we can do that as well. And then you might want to make your first commit. You can do that in the normal way in terminal. To be honest, it works exactly like any other project. And so you can do everything in the terminal. We could git add, and then we could git commit with a message saying initial commit, for example. And that's just, it's done the job. But equally, we could also say use up here. You can see now we've got no changes, but we could say, I don't know, we could redefine our function here, and then save that. Then you can see we've got a change up here, and we can stage it and do all of this. I tend to use the terminal, to be honest, but you've got all of your different buttons in here. It's not going to let me push because we're not actually connected to anything. Don't know what that does. Oh, creates a new branch. That makes sense. Yeah, I don't often use this tab, to be honest. But if you wanted to, you could, right? You could. Ooh, what is this? Oh, there we go. Look at this. There we can commit just straight inside here, which is pretty convenient. Used square function. Actually, let's just put example commit. Otherwise, that's just going to be a really weird commit message. Then we can commit, and great, it's committed. And I can't see what I just typed. Oh, of course, the pop-up. Yeah, I mean, to be honest, it's not particularly exciting, but it's exactly the same as just typing in commit down here. So if you're familiar with Git, this should all be fairly straightforward. If you're not, I would recommend heading along to one of the Git workshops, as I mentioned. What I will do is actually, I might connect this up to a Git repository, because I'm going to be copying and pasting in some big chunks of code later, just for the sake of time, and that would maybe be easier if everyone can just copy and paste directly. So I'm going to create a quick a quick repository on my GitHub, and then I'm going to link it up very nicely. So you just give me one moment. I'm in my GitHub right now, and I am grabbing all the bits and pieces that I need to link us up. So what I'm going to do is I'm going to grab our SSH URL. Actually, let's grab this one. Okay, perfect. So this is like a speed run in Git. If you're not familiar, this might be slightly confusing to you, but that's okay. And so what I'm doing right now is I'm adding in a link to the blank repository that I've made on my GitHub, and then we are linking our local repository to our GitHub, and then we will push. This is as normal. Okay, and that should do the trick. In the future, we can just type git push, and if I go over and head over to my GitHub, it now has things in it, which is great. Yeah, looks like we're pretty good. Perfect. Yeah, doesn't have a README, but that's okay. So if you want to follow on with this project, I will occasionally update this GitHub and throughout the next kind of half an hour or so as we finish. So you can copy and paste things yourself. As you probably saw on screen, it's just called hackviz. So let me type that in. There you go. So you can head along to this repository and follow along. Right. So we've made a basics file. That was for our learning. We're going to, close that now. And actually, maybe we're not going to close that quite yet. Let's first just use it at the end. We want some data, and it would be good to have some, and I'm going to make some very quick hackathon data. Again, this is something which I would recommend you do not try and type out yourself. It's a bit of a hassle, but you can see that we're using lots of the things we are vaguely familiar with from our little basics introduction there. And so here we are creating a data set, and we're randomly generating it into a table, and we're putting in a project ID, a team name, a category which the team submitted to, scores, the number of votes that they've got, the lines of code. This is basically like a data set on all of the projects that you might see at a hackathon, right? You could use this for, whatever, right? But this is just some example data, and we are clamping our score to be between 0 and 100 because we're generating it using a random variable, which technically could be infinite. So if you're not familiar with what the normal distribution looks like, it's that bell curve. And as a little reminder, you can check any of these functions by just asking in the help. And then we see here, hopefully it's got a picture. Doesn't have a picture, that's fine. So the normal distribution is the most famous and common distribution in stats, and I definitely do recommend doing a bit of learning about probability distributions and things if you're not used to them already. So this is just generated and then written a CSV into our project, specifically into our data folder. And if we head along to files and we go back to data, we can see it here, and we can open it up. We can see it's just a CSV, kind of as we'd expect. It's got some pretty standard looking generated data, and we're going to say, okay, maybe our hackathon project, right? And this is going to be what HackViz is visualizing this data set. And that's what we're going to do for the rest of this session. The next half an hour, we're going to put some of our little skills into practice. Most of what we're going to do is going to be, I'm going to paste in some code and kind of talk through roughly how it works. This is going to be a good example on what an initial R project might look like. So we're going to close this basics file and open up a new one, and maybe we will call it data patterns, and we'll say O2 data patterns. Perfect. And probably the first thing you're thinking is, oh, we haven't even learned how to interact with CSVs yet. Well, don't worry. Let's learn how to do that. We will read in that CSV that we just created. So we are going to call it projects, and let's read it in. When we do this, we're just telling R which package to use. This comes from tidyverse, and we will just type in read CSV. Pretty straightforward. We'll give it the path. And again, remember, you can just check the documentation for any of these functions for the syntax and whatever else you want to know about them. So if you have any questions that I can't answer, give that a go. And so we've loaded that in now. Hopefully, if we head over to our environment, there we go, projects up here. And you can see it looking pretty nasty. If we click on it, we get a much better view. That's nice. Thank you, R and RStudio, for visualizing things so nicely for us. When we want to inspect this, we can use something called the glimpse. And the glimpse comes from this library. And this library is part of tidyverse. Again, you can see why we love tidyverse so much. There we go. It's a transposed version of print. So it basically just gives us a nice little introduction to what our data frame is like. If you are working with some new data, this is probably what you would always do first. We can glimpse at it, and this just gives us a bit of a summary. It tells us what data types, these characters, for example. Got some date time data. We can see our project IDs. We can see team names. We can see the categories that they submitted to, the scores that they received, the number of votes that they got, the number of lines of code that they wrote, all this information. But actually, this is not very clear. We'd probably like to learn a bit more. Maybe we can do some little basic data investigation commands. This is just getting the head right. If you're familiar with Python, this will be something you've used many, many times. We're just getting the first 5 rows. We could change it to be 10. We could change it to be 100. I wouldn't do that because it will have a panic and only print out 10 rows anyway, and it kind of defeats the point of using head. But there we go. Perfect. We could also get a summary, which summarizes everything by column. So we can see the length of each of the columns, for example. Okay, 200. You can see a whole bunch of stats, basically. On our scores, we can see that the minimum score is 35, the maximum score is 100. A bunch of other bits and pieces like that. Again, we've got minimum and maximum times. You can see that it's handled the times perfectly, even doing the medians and the means, which is a really great strength of R. And I mentioned earlier that dealing with date time can be really hard and annoying, especially in Python. I hate it. But R does a brilliant job of this. This is a really nice and quick way of getting a summary of our data. We can get the column names by just asking for the names. We can get the number of rows by asking for the number of rows, and also the number of columns by asking for the number of columns. And that's pretty neat. We can see we've got 200 projects, each with 7 variables. And actually, if we head along up to glimpse, I'll just actually rerun that. It tells us 200 rows at 7 columns. So we get all of these summaries. We can do lots of different things to get the summaries. And if we want to manipulate this data, we can do that using these tidyverse verbs. And when I used, for example, select earlier, or arrange, or filter, or mutates, These are all tidyverse verbs, and these are really great, really useful, very convenient, and we could use them for a bunch of different things. For example, we could select some columns, rename some columns, and do that to customize what variables we actually want in our data. So we can make a mini version of our data set, and we could use projects, and we could, for example, use the pipe operator and select just let's say we want the project ID, team name, category, score, votes, lines of code. So we basically just ditched submitted that, and if we run this, doesn't like it. It's because I've typoed. Now it likes it. We can check out mini with glimpse mini. There we go. Great. We can see that we've ditched one of our columns. We've only got 6 columns now instead of the previous 7. We could filter the rows just for, say, we want to just get rows with high scores in, and so let's say we do that with our mini. Oh, that's not what I wanted to do. We do that with mini. There we go. And we could say filter, again, very straightforward. We just say we want the score to be larger than or equal to, I don't know, 88. And then if we check high scores, we've only got 25 teams now. And still the six variables that we expected. If we said we wanted to be bigger than 98, for example, and then we run that, we're going to get just 4 teams. And we can see it's worked pretty successfully. We've got 4 teams that got full marks. Good job, them. We've got their project IDs, their team names, their votes, all of the things that we randomly generated using that code earlier. Awesome. We got someone who's just joined in. No worries at all. This is an introduction to R. I do recommend checking it out on YouTube if you want to see all of the basics that we taught at the start. Right now, we're just going over tidyverse verbs and how we can manipulate data. R is great for manipulating data. We love it. And so that's what we're doing. We could also, on the note of manipulating data, not just filter our data, but also sort it. And these are things which you might be like, oh, yeah, I can do this in Excel. Why would I ever do this in R? Well, if you've ever tried to open a really big bit of data in Excel, you will know that it takes forever. You can't do anything. It's slow. It's unpleasant to deal with. And sometimes it literally just cannot open it. It's too big. And so we are saying, let's sort it. And you see that we did this earlier by score and votes in a descending order. And we will check that we actually oh, that's not a typo. Check that that actually worked. And we can see, what do we sort it by? Scores and then votes in a descending order. So yeah, there we go. Scores, these are all have the same score. So we can see that it was sorted by votes and it's descending. Perfect. That's what we want. Let's say we want to add new columns or transform old columns. Well, then we're going to be using mutate. And we can do that by, again, getting used to using our pipe operator. And copy paste it again because I don't have the bar key on my keyboard. And then we can mutate, and we might want to do a bunch of different things. So let's make a new line. Let's say that we want to add a new column called score band, and we will say when the score is bigger than 85, we'll call it gold in the score band, and when the score is bigger than 70, we'll call it silver, and then when it's nothing else, i.e. just true, we'll call it bronze. And that's great, but then let's also mutate and say we want another column, and it's going to be called votes per 1,000 lines of code, and we'll divide the votes column by the lines of code. And if we run this, we will get augmented, just without the capitals. And let's take a little look. Has it done a good job? Oh, we got a score of 75, so it should be silver, and it is. We got a score of 63. Well, it's less than 70, bronze. Yeah, great. So we can see that this has worked really perfectly, really fast, really fluid, very easy to work with. And then we'll check out votes per 1,000 lines of code. We actually can't see that variable right now, but that's okay. We could even, if we wanted to, manipulate it down so that we only have oh no, this is not in the right place. Make sure that you get your brackets and so on correct. There you go. It should be fine now. There we go. And let's say we wanted to keep just this and the project ID and the score band. We could delete all of these and then we check augmented again, and we can see we've got the votes per 1,000 lines of code. So it's very easy to manipulate data in R. Super, super easy. What if we wanted to, I don't know, group something by its category? Well, we can do that too. So let's say that we want, let's ditch that again, by the way. And we run that, perfect. And let's say we wanted to get from augmented, we want to group by the category, which is the category that we submitted to in our, hypothetical fictional hackathon. And we could then get a little summary according to that. And so we can do a bunch of different things. And this, I'm probably speeding you through a whole load of very new verbs and different methods. Remember this, removing NAs. There's so many different things that you can do in R so easily, so fluidly. And yeah, you can do all of these in Python, right? It's not like one replaces the other entirely, but they do have slightly different functions and use cases, which are unique and gives both of them their own strengths. So knowing R is super useful. And then we could get out the average lines of code as well. So you can see how quickly I'm manipulating the data to do whatever we want. If we run this, and then we get the category summary out, we can see that according to each category, we've got the number of projects that were submitted, the mean score, the median score, and the average lines of code. I think that's pretty impressive how quickly we just got such a useful and neat summary of our data. We can see that the biggest category was climate, but the one with the highest mean score was actually health, that many of them had the same median score, but the average lines of code in climate was also much higher. Super interesting. So we are learning a bit about our data. And let's say we wanted to make a plot. Well, there's a bunch of different plots that we can do. And what we're going to use for our plots is ggplot. And I'm not sure we've actually loaded in... Yeah, I don't think we've loaded in ggplot yet, but we'll give it a go and see what happens. See if we can get a nice little error message popping up. Okay, so let's say we want to make a histogram, or we can use ggplot. And if you are, into the data visualization world, you must have heard of ggplot. It is beautiful. It makes the nicest visualizations, the fastest. It's amazing, and it's completely modular. You can just add bits using this little add operator to build graphs using whatever you like. And you know, in matplotlib, for example, which is probably the closest thing that Python has, you can kind of do some similar things. You can create your axes and your labels and so on. But it's a bit clunky, and it's certainly not as easy to make something beautiful in just a handful of lines of code. And as you can see here, we're on line 5. And in a minute, you'll see that this has very easily created a nice plot for us. That was a bit scuffed for a second there, but there we go. So we've got a plot, super fast, super convenient. I think that's amazing. We can also do a bunch of other different plots. So for example, we can do a box plot or a scatter plot, and I've just pasted some in here. This is a box plot. Again, really quick and easy to do. You can see that it's basically the same lines of code, but we've just changed this one to box plot, and we've changed the variables that we're tracking. We could do the same with a scatter plot. You can see that we've changed it from box plot to points, and we're just adding points with this level of transparency for all of these different bits and pieces. And we're saying, okay, change them based on the category that they are, what color that they have. And so quickly we've made such a quick and I think fairly aesthetic plot. And there's a lot of room for personalization and customization here. It's so flexible and also powerful. So ggplot is really great. Awesome. So I think this is a great point to have reached. We've got about 15 minutes left, and I think the big things that we've learned are the key practices when you're using an R project, when you're using R and building a project, right? So the first thing, and I gave it away there, make an R project, keep all your files inside that, don't use absolute paths. So you will have noticed that when we loaded in our data, we did data/sample projects. We're using relative paths the whole time. And that means that if you're working in a team at a hackathon, you can commit your projects to your GitHub, push it, and other people can pull, and it won't break because they've got absolute paths which are, different across different devices, but actually they're relative paths which only deal with things relative, again, to the project itself. Awesome. We can also, as I mentioned earlier, use our R virtual environment to freeze all of the packages that we're using into this lock. And I'm going to quickly check for questions. See if we've got any. Looks like we don't. No questions is, I feel like, always a good sign. Good sign that we've got happy hackers. Awesome. Okay, so what we want to do when we are making when we're using our virtual environment is we want to initialize it, and we have already done this, but this is how you would do it if you didn't do it when you created the project itself. I don't actually know what it's going to say here. Okay, this isn't where I want to be. This is what we want. There we go. That makes a lot more sense. There we go. And we can see that it already has a log file, and we can do a whole bunch of different bits and pieces. But basically, we're happy, and I'm gonna click 4 and abort that operation. Okay, perfect. And we've installed a bunch of different packages, but what if we want to record the versions that we've got? This is kind of like freezing your installations, and you can do that by typing, again, this same command. This is just saying use this library, and we will do snapshots. We don't need that or that. That was a typo. And if we do this, it will record the exact versions in our lock file. And it's saying, this is what we're going to record. Great. I'm not going to read it all. I don't really care. It's just going to do it for me. And that's super easy. When someone else, let's say they've cloned the repository, someone in your team has cloned the repository, or maybe you're working somewhere and they've cloned the repository, they can just do restore. And it will say, oh, it's already synchronized. That's because we literally just made the snapshot, but that does the trick. You can also activate this if it's not already activated using this command. You can do a whole bunch of different bits and pieces. You can, for example, do status as well, and it will say that everything is exactly the same. Yep. So that's great. Great, perfect. So I think we've reached a point where we have learned a huge amount about how R works and good data practices when we're manipulating our data. What I want to do now is very quickly, I'm going to wipe all of this, and we're going to load in our data and create a very quick visualization. We've got about 5-10 minutes before the end of the workshop, so we'll see how quick I can get on. I've got some code saved, and we'll just run it and see what we can make. And you'll see how short the code is, even though I'm not going to type it out myself. You'll see how short it is and how easy it is to make really great and quick visualizations and apps with R. So this is us loading in our data. We've installed all of our packages. This is the file that we are in, and we can read in our CSV, take a little look. Remember, glimpse is something that we always want to do pretty much immediately. Just ditch some of these comments because they're not always very clear. Yeah, so this is the CSV that we made earlier. We don't need to regenerate it because we've definitely got it saved, but this is a nice little check. And so we'll run this, and there we go. It's pulled out the data that we wanted. This is something we've already done. We've already used glimpse. We're pretty happy with this, but we've just read it in pretty nice and simply. We can also do a bunch of other different bits and pieces in terms of like data validation, checking that column types are correct. I'm going to skip over that because we don't necessarily have all the time that we need to do so. But yeah, this is how we load in our data, and that makes hopefully pretty much perfect sense. One little thing to mention actually while we're here is that you might have some data like this, which is wide. And when we say our data is wide, we mean that it's literally wide. And we might want to make it long, and you'll see the difference now. So we've got maybe, like here, if you say in our comments, we have the number of votes by day. Here we've got, okay, the project ID, and then the day, and then the number of votes. This is long. You can see that it's longer than it is wide. But if we take a look at the wide one, we can see it's wider, well, as wide as it is long. And that's because we've got a variable for each of the votes per day. This is long because we've got just the day and the votes. This is wide because we've got the votes per day in its own variable. Typically, we want data in long format. It's easy to manipulate. This is not so clear. If you're building like an ML model, this is actually a variable that you'll be using and it'll be training from, whereas this is going to be much more complicated and hard to get good results from. Cool. Okay. So this is the data patterns file, and we've basically just done a whole bunch of data manipulation. But we're going to close that and make a new R script, and we're going to call it utils data. And these are a bunch of bits and pieces which allow us to, for example, check that the variables have the correct data types. And like I mentioned, we've got the numeric, but we've also got categorical data types, we've got logicals, and so on. We're also checking for missing values where we're imputing them potentially, and also various other functions that are useful for us. Cool. And I think we'll just save this, and then we're going to make our app.r. And this is, I think, the most fun bit, and I really wanted to get to this just to demonstrate how cool R is. This is going to be using something called Shiny, and Shiny is kind of like, if you've seen any of my workshops before, it's a bit like Streamlit in that you can build really, really fast apps. And so this here is an app that we've got. Set up. Yeah, let's save it. Actually, we'll save it as app.r. We won't put it in script. We'll just put it in the root. And there we go. And we've got it split up into 4 sections. We've got loading our packages, which we've already gone over. We pulled in our data helpers. This is to make sure that we don't have any weird data types. Those are the ones that we just wrote in our utils folder. Sorry, in our utils script even. We don't have our own utils folder in this project. This allows us to make a quick UI, and you can see how short this is. This is unbelievably short, even compared to Streamlit. You can see how short this is, and I'll commit this. It's got loads of comments, so hopefully will make a lot of sense. We've got sliders. We can have checkboxes. We actually, I think, won't have this checkbox because the density is kind of complicated to deal with. Although, actually, yeah, no, let's not. We'll leave it in there. And then we've got the server logic itself. And again, I would recommend you give this a little read through yourself. And then we can launch the app. And as our little comment says here, this is another big advantage of RStudio. We've got this run app button. You'll see this is different to what we had earlier. And we've got a quick question about source code. I'm going to commit all of this. The link is just a little bit up in the chat. I popped up on screen now. But if I run this app, we've immediately got our... Oh, actually, you can't see. Can you let me reshare my screen? That would be better. Give me just one moment. So this is what pops up when we click Run App. And we could open it in browser, but you won't be able to see that because I've only shared this window, but this is what we've made. And in barely any lines of code, we've got a really nice visualization. It's flexible, it's very fast, and we can explore all of our data. We can put in density curves. We've got a summary of the variables that we're dealing with, and so on. And we can actually build even better and more complicated apps even quicker. I've got maybe a couple of minutes. Let's see if I can paste in. Yeah, let's paste in. I'm going to share my screen again. I'm going to share my full screen so you can see what I'm talking about. Right. There we go. Hopefully you can see this now. So I've put in, this is a little bit longer and more complicated, but actually if we run this, and again, we can run it by just going up here and clicking Run App. There are some settings if you want to try. You can also publish your app, and it's going to pop up with a little thing saying I need to connect some bits and pieces. So you need some packages to do this, but you can publish this super easily. And this is one of the great advantages of R, is that you can build an app with a beautiful UI without having to do any of that yourself, and publish it super fast for, you know, I mean, what, we spent 2 hours, and we've got something looking certainly not like finished, but so quickly we've got all of the different this is an interesting box plot. I wouldn't normally suggest using team name as a categorical column, but if we use the category, for example, which we were looking at, climate, education, fintech, health, and open. These are the categories that we had in our fantasy hackathon. Let's not plot the project ID because that doesn't really mean anything. Let's plot the scores so we can see the distribution of the scores. We can see actually the scores are pretty consistent across categories. That would maybe imply that our judges are unbiased. That's pretty cool. We can do a bunch of other different things. We could filter by various different bits and pieces. We could remove the jitter points on our plot or add them back. We can get summaries of what we're doing to our data. You can see all the different tibbles. And yeah, there's loads of things that we can do with this. For example, plotting our score against project ID. Probably not very useful, but plotting our score against the number of votes, maybe slightly more interesting. 4 lines of code, even more interesting, and so on. We could also upload a new CSV. You can see how flexible this is, and we can even do some filtering. This isn't going to work perfectly, to be honest, but we can also filter by score, for example. Say we only want the top scores to be showing, and immediately our plot is updated. We could get just the bottom scores. Amazing. So I'm going to leave it there. Thank you all for coming. As a little reminder, you can give feedback on this session. I hope you found it interesting and a bit of a whirlwind tour, I'm sure, but you're feeling like you could even maybe take a look at R yourself in your own time and at some point build your own Shiny app, which is very satisfying. As you can see, it's super quick and great for a hackathon. Please do give feedback. I'd love to hear what you think. And does ngrok also support RStudio? I don't know, but I would suggest that you wouldn't need it because you can publish directly from RStudio anyway. We could install now. I don't think I've got time. I'm afraid not. And I know someone's hopping in after me, I believe. So definitely check out the next stream. Let's see what the next stream is. We've got, that's perfect. Making better hacks faster with GitHub Copilot. So all those people who were asking a little bit about Copilot earlier had some queries. Definitely head along, check that out. It's going to be really great. With that, I'll leave it there. Thank you all for coming. It's been great to see you all, and I will see you another time. Please do give me some feedback, and I'll see you soon. Thank you.